Namaste to everyone. I welcome you all in my YouTube video channel. Today I will deliver lecture on analytical dynamics or classical mechanics, chapter variational principle, lecture number 3, in which I will solve problems on principle of least action. Now we solve a problem. Problem is a particle of unit mass is projected so that its total energy is H in a field of force of which the potential energy is phi r, means function of r, at a distance r from the origin. Deduce from the principle of energy and least action that the differential equation of path is c square curly bracket r square plus dr by d theta whole square curly bracket closed equal to r to the power 4 curly bracket h minus phi r. This is the first part. Establish a correspondence between the possible free paths and geodesics on a certain surface of revolution. Now we solve this. Let A equal to action of the dynamical system implies that A equal to integration limit t1 to t2 sigma I pi qi dot dt. This equal to integration limit t1 to t2 sigma I pi means momentum mass into velocity mi qi dot with the velocity qi dot dt, since momentum pi equal to mi qi dot, and this will be equal to integration limit t1 to t2 sigma I mi qi dot square dt. This equal to 2 multiply integration limit t1 to t2 sigma I, here we give half, here 2, here half, mi qi dot square dt. This equal to 2 integration limit t1 to t2, and this amount is t, kinetic energy, half mv square, velocity square, here sigma. So this is t dt, since kinetic energy t equal to half mv square, velocity v equal to velocity, this equal to integration limit t1 to t2 to t dt. This is action. This is number 1. Since by principle of least action delta A equal to 0 implies that delta A is integration limit t1 to t2 2t dt equal to 0. Let this is number 2. Given that potential energy V is the function of R. This is number 3. Also given that total energy equal to H. Here its total energy is H. Let this is number 4. Implies that T plus V, total energy, kinetic energy plus potential energy equal to H, implies that T equal to H minus V. H minus V means phi R. Let this is number 5. Given that mass of the particle is unity, means 1. Let coordinates of the particle at any time t is r theta. Therefore, x equal to r cos theta, y equal to r sin theta, implies that x dot equal to r dot cos theta. Differentiation of cos theta is minus sin theta, so we write here minus r. Differentiation of cos theta is minus sin theta, and differentiation of theta with respect to t is theta dot, and y dot. Dot means derivative with respect to time t, and this will be equal to r dot sin theta plus r. Differentiation of sin theta is cos theta, and differentiation of theta is theta dot, implies that x dot square plus y dot square equal to r dot cos theta minus r sin theta theta dot whole square plus r dot sin theta plus r cos theta theta dot. This will be curly bracket, here curly bracket square, and this will be equal to r dot square cos square theta plus r square sin square theta theta dot square minus 2r r dot sin theta cos theta theta dot plus r dot square sin square theta plus r square cos square theta theta dot square plus 2r r dot sin theta cos theta theta dot. Here this term and this term cancel out, so remains, here we take common r dot square cos square theta plus sin square theta plus, here we take common r square theta dot square, r square theta dot square, sin square theta plus cos square theta implies that x dot square plus y dot square equal to r dot square plus r square theta dot square. This is number 6. Since kinetic energy of the particle equal to half m is 1 velocity square, half v square is x dot square plus y dot square. Here v be the velocity and this will be equal to half, implies that here T kinetic energy is T half x dot square plus y dot square is r dot square plus r square theta dot square, implies that 2t equal to r dot square plus r square theta dot square. This is number 7. Implies that 2 using 5 t equal to h minus phi r equal to, here r dot square means dr by dt whole square plus r square d theta by dt whole square, implies that 2h minus phi r, here dt square equal to dr square plus r square d theta square, implies that square root 2 h minus phi r dt equal to square root dr square plus r square d theta square. This is power half, taking square root both sides. dt equal to square root dr square plus r square d theta square by square root h minus phi r to the power half. That this is number 8. Using 5 and 8 into, we get delta integration t1 to t2 to t dt equal to delta integration t1 to t2 limit to t means h minus phi r and dt means square root dr square plus r square d theta square by square root 2 h minus phi r to the power half. This equal to square root 2 outside delta. Here h minus phi r to the power half. Here to the power half, here power 1. Here dr square, if we take common, 1 plus r square d theta by dr square square root bracket closed. Here this is 0, right side 0 into this is implies this equal to 0, implies that delta, we may send square root to right side, so only remains integration t1 to t2 h minus phi r to the power half. Here square root 1 plus r square, we may write this as theta prime. Theta prime means d theta by dr square dr equal to 0. Let theta prime equal to d theta by dr. Let this is number 9. Let h minus phi r to the power half square root 1 plus r square theta prime square equal to f function of r theta theta prime. This is number 10. Therefore 9 may be written as delta integration limit t1 to t2 f r theta theta prime dr equal to 0. This is number 11. Therefore, by Euler's equation, d by dr, partial derivative of f with respect to theta prime minus partial derivative of f with respect to theta equal to 0. Let this is number 12. Since from 10 we see that f does not contain theta explicitly. Here we see h, here r, here theta prime. Here there is no theta in left side. Therefore, partial derivative of f with respect to theta equal to 0. This is number 13. Using 13 in 12, we get d by dr, partial derivative of f with respect to theta prime equal to 0. Integrating, we get partial derivative of f with respect to theta prime equal to c, a constant. Let this is number 14. Since partial derivative of f with respect to theta prime equal to, here we do not get any theta prime, so this will be treated as constant to the power half. Here 1 by 2 square root 1 plus r square theta prime square multiply here r square multiply 2 theta prime, this equal to h minus phi r to the power half, 2 cancel, so remains theta prime r square by square root 1 plus r square theta prime square. Here partial derivative of f with respect to theta prime is c, so we write left side c, implies that c equal to h minus phi r to the power half theta prime r square by square root 1 plus r square theta prime square, implies that we write this h minus phi r to the power half r square equal to c square root 1 plus r square theta prime square by theta prime, squaring both sides, h minus phi r to the power 4 c square 1 plus r square theta prime square by theta prime square, implies that h minus phi r to the power 4 equal to, this is c square, here we write 1 by theta prime square plus r square, implies that h minus phi r to the power 4 equal to c square, we may write this dr by d theta whole square plus r square, implies that h minus phi r to the power 4 equal to c square r square plus dr by d theta whole square. Therefore, first part proved. Let this is number 15. Since x equal to r cos theta, y equal to r sin theta, implies that dx equal to dr cos theta plus r constant, derivative of cos theta, sin theta minus sin theta, d theta dy equal to dr sin theta plus r, differentiation of sin theta is cos theta d theta, implies that dx square plus dy square equal to we may get this dr square plus r square d theta square. This is number 16. Implies that dx square plus dy square is ds square equal to dr square plus r square d theta square. We take common dr square. Here remains 1. Here r square d theta by dr whole square. This equal to dr square 1 plus r square d theta by dr is theta prime square. Taking square root both sides, ds equal to 1 plus r square theta prime square to the power half dr. This is equation number 17. Since for geodesic we have delta integration ds equal to 0, implies that delta integration ds equal to this square root 1 plus r square theta prime square dr equal to 0. This is number 18. From 9 we have delta integration h minus phi r to the power half square root 1 plus r square theta prime square dr equal to 0. This is number 19. Comparing (18) and 19, we get that equation 19 is for possible free paths and this is for geodesic curve. The possible free path will be geodesic curve if h minus phi r to the power half equal to constant k implies that h minus phi r squaring both sides equal to k square, a constant. This is kinetic energy T, a constant. T equal to kinetic energy. Therefore, the possible free paths will be a geodesic curve. If the kinetic energy T is constant. This is the required result. Thanks for watching my video. If you are satisfied with my presentation and contents, then please click on like button and do subscribe my YouTube channel. Thank you.